Good afternoon, everybody. This is Mr. Breton again. Today we're going to be reading or continuing our reading on weather. Today we got three different areas I want to cover as it relates to weather. So let's get started. I'm going to talk about winds, the wind that blows outside first. Wind is moving air, and air movement are caused by differences in air pressure and temperature. Air pressure is the weight of air pressing down on the Earth's surface. Winds flow from high pressure to low pressure areas. Pressure is high where air sinks and low where it rises. Temperature differences make air move because warm air is light and cold air is heavy. So cold air always flows in to replace the warm air that is rising. One place where this happens is on the seashore during a hot summer weather. Land warms up faster than the water, so a sea breeze blows towards the shore in the morning. At night, a land breeze blows out to sea because the water takes longer to cool. Winds range from gentle breezes to great rivers of air that blow around the world. From the equator, which is the middle of the earth, warm air rises and spreads out over the tropics. From the edges of the tropics, strong, steady trade winds blow back toward the equator, and a mild westerly wind blows towards north and south poles. When the cold easterlies from the pole clash with the warm westerlies, the winds whirl around each other, and they're also known as cyclones or depressions. These spiral of low-pressure air bring cloudy or windy weather and rain or snow. At the edge of the tropics, air from the equator cools and sinks, creating spirals of high-pressure air called anticyclones. Anticyclones bring clear skies and sunshine in the summer, and in winter it can bring cold weather, frost, and fog. And hot air balloons, and that's a cyclone right there. So I'm going to talk about wild weather, and we live in Texas, so there's always wild weather in Texas. We have tornadoes and hailstorms, hurricanes. So let's read about wild weather. Thunderstorms unleash enormous power and energy. Lightning is a massive electric spark jumping between the clouds and from cloud to the ground. Thunder and lightning happened at the same moment, but lightning seems to come first because light travels faster than sound. Lightning heats air as much as 86,000 degrees Fahrenheit. The intense heat makes the air expand with a bag or a rumble. Hurricanes are violent storms produced by moist air and heat rising from the tropical sea in the late summer. As the hot air escapes upward, cool air spirals in to replace it because the Earth's spin. Moisture in the rising air condenses into clouds, and after several hours and days, the storm begin. At the center of the spiral is a calm spot called the eye. So it's the eye of the hurricane. At the center of the around it, the winds whirl up to 200 miles per hour. Tornadoes are like mini hurricanes, but they start over land because they are so concentrated. Tornadoes are even more violent than hurricanes. You can see the bad weather, the lightning coming from the clouds. And that's a tornado right there. And then the last thing I want to talk today is about forecasting weather. So this is like a weather person that you'll see on the news or on maybe around town at your school. So forecasting the weather. Once, people could only guess what tomorrow's weather would be like. Now, scientists can forecast the weather fairly accurately, though they do not always get it right. In 1987, only hours before England was struck by a hurricane, a forecaster reassured television viewers that a hurricane was not expected. Forecasts help farmers plan the work on their crops. Pilots can be told how to make the best use of the winds. We can plan outings and holidays, and people can stock up on food if a bad storm is forecast. Correct forecasting needs weather information, night and day, from places all around the world. This is collected from manned and unmanned weather stations that are around land or sea. Meteorologists is what you'll see on TV here. You have meteorologists, they're weather people, or weather scientists use a variety of instruments to record air temperature and pressure, humidity, and humidity is the moisture in the air. Like here, we have a lot of moisture in the air during the summer in the Houston area, and wind speed. Instruments sent up by balloon give radio reports of the weather in the upper air. Radar screens show approaching showers and storms. So you probably watch the news sometime and you'll see some radar. If there's a storm coming through, they'll show it on the screen. Satellites now gaze down upon the world's weather like ever open eyes to the sky. Their instruments monitor all weather changes. They can spot waves of ruffle by the wind or the beginnings of a hurricane. And the last thing about forecasting weather are their satellites beam all the information and code back to the Earth. Receiving equipment on the ground turns the information into weather maps and displays on the screens. To forecast the world's weather for the next 24 hours means making about 500 million calculations. That's a lot. Only the world's most powerful supercomputers work fast enough to tackle such a giant task. I hope you enjoyed reading some more of the weather book for day 2. We'll read a few more weather type items Thursday and Friday. You have a great day. Bye.